Hey, this is Mr. Molo for lesson 2-3, solving inequalities using multiplication or division. So very similar to the lesson we just did about adding and subtracting, except this one's going to be multiplying and dividing. So this table kind of sets things up for us, kind of step by step. So it already did the first one for us. So if I plug in -1 to this problem, so 3 times -1, I get -3. And then it's asking if 6 is less than that. Well, 6 is not less than -3, so I wrote a no for us. Okay, and we're going to fill out the rest of this table then. So if I put in a 0, 3 times 0 is 0. Is 6 less than 0? Well, we got another no there. Let's put in 1. 3 times 1 is 3. Is 6 less than 3? Again, we end up with another no. 2, this one's kind of tricky. 3 times 2 is 6. Is 6 less than 6? Since it's just a less than sign, we're going to have to say no. It's equal to 6, but it's not a less than or equal to sign. All right, and then we have 3 times 3 now. That gives us 9. Is 6 less than 9? So now we can finally put a yes. 4, 3 times 4 is 12. Is 6 less than 12? Again, we could put a yes. And then 5, 3 times 5 is 15. And 6 is less than 15. So that's a yes as well. So now we're going to kind of just try and find for each of these problems, where's the turning point? At what point is this problem going to be true? And we could also have just solved it this way. That says 3 times x. So I need to divide both sides by 3. So this tells us right here, I needed x to be a number bigger than 2. And that was pretty much what happened. I needed to be bigger than 2. So starting at 3, that's when it is. All right, let's look at one more like this. And now it's a -3. And you'll kind of see why this changes. And there's one rule, and I'm going to do it wrong on purpose. So warning, this is wrong. Okay, so if you're yelling at the screen right now saying, Mr. Muller, you're doing it wrong. I know, this is on purpose. All right, so I'm going to divide both sides by -3. Divide both sides by -3. I get -2 is less than x. Again, that is the wrong answer. Don't yell at me yet. All right, so let's try this. So I have -5 here. -3 times -5 is a +15. Is 6 less than 15? Yes, it is. So we're going to put a yes here. Same thing here. I have a -4. -3 times -4 is a +12. 6 is less than +12. So we start off with another yes. -3. So -3 times -3 is a +9. 6 is less than 9, so we have another yes. Now we end up with -2. -3 times -2 is +6. 6 is not less than 6, it's equal to 6, so we're going to have to put a no there. -1, so times -3 is a +3. 6 is not less than 3, so we end up with a 0 there. -3 times 0 is 0. 6 is not less than 0, so another no. And -3 times 1 is -3. And so we end up with another no because 6 is not less than -3. So you'll see kind of the mistake here and why we need to do this. Again, all about why. X is greater than -2. Okay? If you pick numbers that are greater than -2, like -1, 0, 1, 2, 3, that's not going to be a true equation. Numbers greater than -2 are like 1 is greater than -2. But 1 wasn't an answer. So when we have something like this, where we have an inequality and we multiply or divide by a negative, what we have to end up doing is flipping our sign as well. So the -2 was right and the x was right, but I'm going to flip this sign from a less than sign to a greater than sign. Okay, so now when I write it this way, I need a number less than -2, like let's say -5 is less than -2. And hey, -5 ended up working, okay? So do not forget, only when you multiply or divide by a negative, you have to flip your sign. If it's a less than sign, it flips to a greater than sign. If it's a greater than sign, it flips to a less than sign. And this is why. The math does not work out if you don't flip your sign. It ends up being actually the exact opposite of what you need it to be. All right, let's look at some more examples. All right, so number 1 here, too far. All right, so 6 times x is less than negative 30. So I'm going to divide both sides by 6. So I get x is less than negative 5. Okay, no sign flipping there. I divided each side by a positive 6. Okay, so on my graph here, I'm going to put a negative 5. I'm also going to put an open circle because it's just a less than sign, not a less than or equal to. And numbers less than negative 5 end up getting shaded to the left, like negative 6, negative 7, negative 8, negative 9, all those. Okay, here I got 16 times f, so I'm going to divide by 16. 48 divided by 16 is 3, so 3 is less than or equal to f. I'm going to rewrite that so my f is first, so f is greater than or equal to 3. I'm going to put a filled-in circle this time at 3 because it's equal to, and f is greater than or equal to 3, so I want numbers like 4, 5, 6, 7, all those going to the right. Okay, I'm going to skip number 3 for a second, and let's look at number 4. So here, negative 4 times m, so I'm going to divide both sides by negative 4. And here's the trick. So I divided both sides by a negative. So it was a greater than sign. I'm going to flip it to a less than or equal to sign. Negative 16 divided by negative 4 is a positive 4. Same thing, I'm going to have an open circle or filled in circle because it's equal to. Numbers less than 4 go to the left, like 3, 2, 1. Okay, so all the numbers shaded to the left. So notice how the sign got flipped. It was a greater than sign, but since I divided by a negative, I flipped it to a less than sign. All right, same thing with number 5. This is x divided by negative 6, so I'm going to times by negative 6. And then same rule still applies. It was a greater than sign. I'm going to flip it to a less than sign because I multiplied by a negative 6. And 1/3 of negative 6 is a negative 2. So I'm going to put negative 2 on my number line, open circle because it's not equal to, and I need numbers less than negative 2, like negative 3, negative 4, negative 5, negative 6. So numbers all going to the left. All right, now let's go look into this fraction one. So 3/7 times f. So remember, I can multiply by 7/3 from each side, and that's the same thing. Notice how I'm multiplying by a positive 7/3, so nothing's going to need to flip here. And then I get 7 times 6 is 42. 3 times 7 is 21. And then I could end up simplifying 42 over 21 as negative 2. So then I get negative 2 is less than or equal to f. I don't like it when the number's first, so I'm going to flop that around. So f is greater than or equal to negative 2. I'm going to put negative 2 on my number line here. I'm going to do a filled-in circle because it's equal to. The numbers greater than negative 2 go to the right, like negative 1, 0, 1, 2, 3, 4, 5. All right, let's look at some more on the back page here. So again, some more fractions. So I have 1 is less than or equal to negative 1/4 y. So same thing, I'm going to multiply by the opposite. So I'm going to multiply by negative 4. So those cancel out. Negative 1 or negative 4 times a positive 1 is a negative 4. I ended up multiplying by a negative, so my sign needs to get flipped. So it was a less than or equal to sign, and I'm going to flip it to a greater than or equal to sign. So negative 4 is greater than or equal to y. Again, I don't like it when my number's first, so I'm going to flip it back to put my number first. So filled in circle at negative 4. And my numbers less than negative 4, like negative 5, negative 6, negative 7, negative 8. All right. Now let's look at this word problem here. So there are at most 36 red and blue marbles in the bag. The number of red marbles is twice the number of blue marbles. Write and solve an inequality that represents the number of red marbles in the bag. Okay. So I know that there's some red marbles in the bag. Let's just use the color red. And I know there's twice as many red as blue. So another way to say that is I know that there's half as many in there. Okay, so I have r plus 1/2 r, ends up being 1.5 r. Has to be at least, or at most, 36. I divide both sides by 1.5. That gives me 24. So at most there's 24 red ones, which means that if there's 36 total, that means the most that there could be are 12 blue ones. And then let's look at number 7. I just realized that one was different. So negative 2/3 is less than negative 4x. So I'm going to divide both sides by a negative 4. And kind of the same thing. Remember, dividing is the same as multiplying by the reciprocal like we did here. So instead of dividing both sides by negative 4, I'm going to end up multiplying by negative 1/4. That makes this one a little easier then, a little less math. So negative 1 times 2 is 2. 4 times 3 is 12. There's 2 negatives, so the positive now. And then that simplifies to 1/6. It was a less than sign, so I flip it to a greater than sign because I divided by negative 4, also multiplying by negative 1/4. Again, I don't like it when my numbers first, so I'm going to flip it. So x is less than positive 1/6. I'm going to put 1/6 here with an open circle. The numbers less than that go to the left, like 0 and negative 1 and all those. All right, let's look at number 8. So kind of the same thing, negative 4/5 times x. So I'm going to divide by negative 4/5. Remember, that's the same as multiplying by negative 5/4. So 2 times 5 is 10. 1 times 4 is 4. So that kind of simplifies to 2.5. And same thing as before, I multiplied by negative 5/4, aka divided by negative 4/5. So my sign's going to get flipped. So it was a greater than or equal to sign. Now it flips to a less than or equal to sign. So x is less than or equal to 2.5. Since it's an equal to, I'm going to put a filled in circle. And numbers less than 2.5 go to the left, like 2, 1, 0.